Did you know that HPLC, or high-performance liquid chromatography, is capable of separating, identifying, and quantifying components in a mixture with such precision that it's used in everything from pharmaceuticals to forensics? Yes, you heard it right. HPLC is a powerful analytical technique that serves as the backbone of countless scientific endeavors. It's like a detective, probing into the heart of a mixture and revealing its most intimate secrets. Imagine a cocktail of substances, each with its own unique properties. How do you tell them apart? How do you measure their individual concentrations? That's where HPLC steps in, acting as a sophisticated sieve that sorts and identifies these components with remarkable accuracy. From developing new drugs to solving crime mysteries, HPLC plays a pivotal role. Now that we've established the significance of HPLC, let's dive into the intricacies of one of its most crucial aspects, the internal standards. In the world of HPLC, internal standards are like the unsung heroes, working behind the scenes to ensure accuracy and reliability. To begin with, let's understand what an internal standard is. In the simplest terms, an internal standard is a known compound different from the analyte that is added in a constant amount to all samples, calibration standards, and quality control samples. It works as a benchmark, allowing us to account for variations that might occur during the analysis, such as sample loss, variations in sample volume, or instrumental fluctuations. But why do we use an internal standard? Well, the purpose of an internal standard is to improve the precision of results. By using a known quantity of an internal standard, we can minimize the impact of experimental variables. It's like having a reliable compass in the ever-changing sea of chemical analysis. Now, how does an internal standard enhance the precision of HPLC? High-performance liquid chromatography, or HPLC, is a technique in analytical chemistry used to separate, identify, and quantify each component in a mixture. It relies on pumps to pass a pressurized liquid solvent containing the sample mixture through a column filled with a solid adsorbent material. Each component in the sample interacts slightly differently with the adsorbent material, causing different flow rates for the different components and leading to the separation of the components as they flow out of the column. Adding an internal standard to this mix, we can correct for these differences in flow rates. The ratio of the signal of the analyte to the signal of the internal standard will remain constant, regardless of any variations in the procedure. This allows us to obtain a more precise quantification of the analyte. In essence, internal standards act as a constant reference point, enabling us to obtain accurate results even amidst variable conditions. They are a critical component in ensuring the reliability of HPLC, making them unsung heroes indeed. Now, isn't that something to appreciate the next time you're involved in an HPLC analysis? So, how do these internal standards function within the realm of HPLC? Well, let's dive right into it. The role of internal standards is to correct any variations that might occur during sample preparation and analysis. They're like the unsung heroes of the HPLC process, working behind the scenes to ensure accuracy and reliability in your results. So imagine you're preparing a sample for HPLC analysis. First, you add your sample to the HPLC system. Now, this is where the internal standard comes into play. You add a known amount of this internal standard to your sample. The key here is that this internal standard has a similar behavior to the analyte, the substance you're trying to measure, but it's distinctly different, so it can be easily differentiated in the analysis. As your sample goes through the HPLC process, it may experience a variety of changes. Changes in volume, degradation of the sample, or variations in injection volume can all affect your final results. But here's the magic of the internal standard. It's subjected to the same conditions as your analyte. So any changes that affect your sample will also affect the internal standard in the same way. Now, when the analysis takes place, the system measures the ratio of the analyte to the internal standard. If there were any changes during the process, both the analyte and internal standard would be affected equally, maintaining the ratio. This is the crux of the internal standard method. It allows us to correct for any variations that occurred during sample preparation and analysis, giving us more accurate and reliable results. So, in essence, the internal standard acts as a kind of control, a touchstone that allows us to account for and correct potential errors in the process. It's like having a built-in error correction system, ensuring that the results you get are as accurate as they can possibly be. So through their consistent behavior, internal standards allow us to correct potential errors and achieve more reliable results. Now that we understand their role, how do we actually implement internal standards in HPLC? Well, the process of adding an internal standard to a sample in high-performance liquid chromatography, or HPLC, is a crucial one and involves a series of methodical steps. Let's dive into it. First off, we need to select an appropriate internal standard. This choice is of paramount importance as it can directly affect the accuracy of the results. The internal standard should ideally be a substance that is chemically similar but not identical to the analyte of interest. It should also be unaffected by the sample preparation steps. In addition, it should not interfere with the analyte signal, and its response factor should be consistent. Once we have our internal standard selected, it's time to prepare the sample. The internal standard is added to the sample in a known amount before the extraction process. This means it undergoes the same sample preparation and analysis conditions as the analyte, which helps to account for any potential losses during sample preparation or changes during analysis. Next, we run the HPLC analysis. Both the analyte and the internal standard are co-eluted, meaning they are forced through the chromatographic system at the same time. This allows for the internal standard to compensate for any variations in injection volume, flow rate, or detector response that could affect the analyte signal. The final step involves using the internal standard to calculate the amount of analyte in the sample. This is done by comparing the response of the analyte to the response of the internal standard using a calibration curve. And there you have it. That's how you implement an internal standard in HPLC. The process might seem a bit complex at first, but with practice, it becomes second nature. By carefully selecting and implementing the internal standard, we can significantly enhance the accuracy and reliability of our HPLC analysis. So, let's summarize what we've learned about internal standards in HPLC. High-performance liquid chromatography, or HPLC, is a powerful tool in the world of analytical chemistry, and internal standards are the unsung heroes that ensure our results are accurate and reliable. We've delved into the complex world of HPLC, and we've discovered that internal standards are not just a luxury, but a necessity. We began our journey by demystifying internal standards. We learned that these are substances of known concentration added to our samples that help to account for any variations during the analysis process. They are like the steady hand guiding the ship amidst the turbulent waves of potential analytical errors, ensuring that our results remain consistent and trustworthy. We then explored the pivotal role of internal standards. They are not merely bystanders in the HPLC process. They are active participants, helping to correct for losses during sample preparation, variations in injection volume, and fluctuations in detector response. They are the guardians of accuracy, impartial in their duty, and unwavering in their commitment to reliable data. Our journey then took us to the practical side of things, implementing internal standards in HPLC. We discovered that the internal standard should be chemically similar, but not identical to the analyte. It should be absent in the sample, and its behavior during HPLC should mirror that of the analyte. It's a delicate balancing act, but when done right, it can make all the difference in our results. So, there you have it. The power of HPLC, the mystery of internal standards, their critical role, and their practical implementation. It's a lot to take in, but remember, every great journey begins with a single step. And in the realm of HPLC, that step is often taken with the aid of an internal standard. Remember, in the world of HPLC, the internal standard is your trusty sidekick, ensuring your results are as accurate and reliable as possible. And with that, we've uncovered the secret world of internal standards in high-performance liquid chromatography. But remember, this is just the tip of the iceberg. The vast ocean of knowledge that lies beneath this topic is waiting for your exploration. Perhaps you might be intrigued to delve deeper into the intricacies of HPLC. Or maybe your interest has been piqued about other analytical techniques in chemistry. There's always more to learn, more to discover. The world of science is a vast expanse, teeming with mysteries and marvels waiting for you to uncover. So let's keep this journey of discovery going. Let's continue to probe, to question, to learn. Because in the realm of science, every question answered leads to a dozen more questions. If you enjoyed this journey into the world of HPLC, don't forget to subscribe for more mind-blowing science content.